Okay, hello and welcome back. In this video, we're covering section 6.3. It's called Special Products. We're still in the topic of multiplying polynomials. So these are certain products of two polynomials of certain forms that show up a lot. So they have particular patterns that we can utilize. So we'll start with finding the product of two binomials in this form, a plus b times a minus b. We will square binomials, so that's looking at something like a plus or minus b squared. And then we'll see a strategy for finding higher powers of binomials, so higher than just the second power. So let's first take a look at polynomials multiplied of this form, a plus b times a minus b. A simple example would be something like x plus 6 times x minus 6. So we have the same two terms, x and 6, and in one factor, in one set of parentheses, it's being added, and then in the second, they're being subtracted. So let's just multiply this out as we've done previously using FOIL, so by multiplying the first, outer, inner, and last terms. And let's see what we get, and see if we can see the general pattern. So the first two terms multiplied will be x times x. Then our outer terms will be x times negative 6. So plus x times negative 6. Then the inner terms will be positive 6 in x. So I can write that as, we'll just stick with the order. So 6 times x. And then the last two terms is 6 times negative 6. So positive 6 times negative 6. So quick review on FOILing. So let's simplify everything. This would give us x squared minus 6x plus 6x minus 36. Notice these two inner terms will cancel out. We have one that's positive and one that's negative. So that will give us x squared minus 36. So notice our two terms that we were working with was x and 6. We could easily write this as x squared, and then we got the 36 by squaring the 6. So x squared minus 6 squared. So let's see the general pattern. If we have something like x plus 6 times x minus 6, we're saying this will be equal to the first term squared minus the second term squared. So we can say in general, something in the form a plus b times a minus b is equal to a squared minus b squared. So we get this difference of squares, to use that term. So let's practice using this. We'll go through the full multiplication first, once again, just to see this pattern once more, and then we can start utilizing the pattern, and it will save us a few steps of work. And they give the general rule here as well. So this is the product of the sum and difference of two terms. A plus b times a minus b multiplies out to a squared minus b squared. The first thing squared minus the second thing squared. So let's try multiplying these out. We'll start with a. We have z plus 9 times z minus 9. So we have that situation. Same two terms, but one with a plus and one with a minus. So let's just multiply this out in the full way using foiling just to see once more this pattern emerge. So the first two terms would be z times z, or z squared. Then the outer terms would be z times negative 9, so minus 9z. Then the inner terms is 9 times z, so plus 9z. Then the outer terms will be 9 times negative 9, or negative 81. We get the cancellation of the middle terms again. Those will cancel. So we just end up with z squared minus 81. So let's do it again and just apply that pattern. Because we see we have something plus something times that same thing minus the same thing. So this should be able to be written as our first term, which is z squared, minus our second term, which is 9, also squared. And that will give us our z squared minus 81. So let's use that same pattern, and we can skip that middle step of multiplying it out and jump straight towards the conclusion here. So for part B, we're given 2 plus c times 2 minus c. So our a term is 2 and our b term is c. So this must equal our first term squared, which is 2 squared, minus our second term, c squared, or 4 minus c squared. Part C, it's a little more complicated now. So we have 5n squared minus 8 times 5n squared plus 8. So the pattern will be the same. We just have a term that's a little bit more complicated for our a term. Our a term is this entire term here, the 5n squared. So that whole thing, in parentheses, 5n squared, will be squared. That's our a squared, minus b squared. Our b term is 8. So if we are raising something to a power that's been multiplied, we can apply the second power to both of those terms, meaning this would become 5 squared times n squared squared. 8 squared is 64. Our 5 squared here will give us 25, 5 times 5. And then recall, when you raise a power to another power, the powers multiply. So the 2 and the 2 would multiply. So this should give us overall 25 times n to the 4th power minus 64. All right, let's look at part D. Now we have 3/4 t, 3 over 4 times t plus u times 3 over 4 t minus u. So we have a fraction, but the same rules will apply. We'll just take our first term, maybe in some parentheses, 3 over 4 t, that will be squared. And then we will subtract our second term, which is u squared. So we'll apply the square to both of these terms. When we raise a fraction to a power, the power applies to the numerator and the denominator. You can imagine just multiplying that fraction by itself. So that should become 9 over 16. And then we will get t squared minus u squared. So the same pattern applies if we have a fraction. Just be careful with the rules of exponents. But this is extremely useful. It can save us some work. We don't have to do this middle part. But the key is that we have to be in this situation where we have a plus b times a minus b, where the two terms are the same, like here, 5n squared and 8. 5n squared is 8 and 8. 5n squared and 8. And the only thing that's different between the two multiplied factors are a plus and minus. One is plus and the other is minus. Okay, we can also generate a special pattern for the square of a binomial. That would be something like x plus 5 squared. Something times itself. So let's see what this would be like just multiplying it out all the way. We can write this as x plus 5 times x plus 5. So foiling this out, the first two multiplied would be x times x, so x squared. Then the outer is x and 5, so plus 5x. Then our inner is 5 times x, so we get another 5x. And then the last is 5 times 5, so that will give us positive 25. This time we have two middle terms that are the same, so they'll combine together. That's x squared plus 10x. But I can write it like this, plus 2 times 5x, just to show this pattern. In reality, I would write that as a 10x. But notice this is our first term squared. If we can consider x our a and 5 is our b, a plus b squared. So our first term squared plus 2 times the multiplication of our two terms. We have 5 and x. When they multiply, we got 5x. So yeah, we produced this double middle term. So we have two of those. And then the last term is our b term squared. So I can even write this instead of 25 as 5 squared. Just to show there is our, if this is a plus b, there's our a squared. You can write this as plus 2 times a times b. And then there is b squared. That will be our general pattern. So I have something like a plus b squared. That should give me a squared plus 2 times a times b plus b squared. And if there's a subtraction, if this is a minus b squared, we'll still get this double middle term, but they would both be negative. So we still have an a squared. The only difference is we'll have minus 2ab instead of plus. And we'll still have plus b squared because the negatives will cancel, become positive. So let's use this pattern for the square of a binomial. A plus b squared is a squared plus 2ab plus b squared. And a minus b squared is a squared minus 2ab plus b squared. So let's practice example 2, part A. We're given d plus 7 squared. So the d is our a and 7 is our b. So using this first pattern, we should get our first term squared, so d squared. We have a plus, so there'll be a plus here. So plus 2 times a times b, so 2 times d times 7, plus our second term squared, so plus 7 squared. So that will give us d squared plus 14d plus 49. So let's try part B. We have m minus 9 squared. So now we have a minus, but the pattern will still hold. We'll just use this second pattern. So it will be our first term squared, so m squared, minus 2 times m times 9, plus our second term, 9 squared. So that will give us m squared minus 18m plus 81. So if you have a minus here, everything's the same as having a plus except for this middle term becomes negative. Our other two terms will stay positive. Okay, part C. We have 2x minus 5y squared. So our terms are a little bit more complicated, but let's still follow the general pattern. So this should be our first term squared, so 2m squared. We have a minus, so we'll have a minus here. So minus 2 times our first term, 2x, times our second term, 5y, plus our second term squared, 5y squared. So 2m times 2m will be 4m squared. The 2 gets squared and the m gets squared as well. Then we'll have minus 2 times 5, so that would be 20 x times y. So all of that is multiplied together. Then plus the 5 will get squared, become 25, and then we'll have y squared. So 4x squared minus 20xy plus 25y squared. All right, and then part D, we have 1/3 t plus 4 squared. So let's follow the same pattern. We'll have our first term squared, so 1/3 t squared plus 2 times our first term times our second term plus our second term squared. So 1/3 times 1/3 should give us 1/9, and t times t gives us t squared. Here we have 2 times 1/3 times 4. So just imagine these are all fractions. We can say like 2/1 times 1/3 times 4/1. So multiply all the numerators. 2 times 1 times 4 will give us 8. Then multiply all the denominators. 1 times 3 times 1 gives us 3. So 8/3. So plus 8/3 t, and then 4 squared is 16. So just be careful with the fractions, but the same pattern will apply. Okay, then our last section is finding higher powers of a binomial. So something greater than the second power. So let's see, our first example is n plus 2 cubed. Well, we can write this as n plus 2 squared times another n plus 2. Really, we have three of these, n plus 2 times n plus 2 times n plus 2. So we can pair two of those together as a squared binomial and apply our previous rule. So let's multiply this first piece out, and then we'll multiply the result with what's left over. So n plus 2 squared should follow that pattern by a plus b squared. That should be a squared plus 2 times a times b plus b squared. You can always just FOIL this out if you forget the pattern, but recognizing and being used to this pattern will just make a lot of problems a lot quicker and easier once you get comfortable. So n plus 2 squared, we'll have our first term squared, n squared, plus 2 times our first term times our second term, 2 times n times 2, plus our second term squared. And then we'll still have n plus 2 multiplied on the outside. So simplifying things a bit, that will be n squared plus 4n plus 4 times n plus 2. Eventually you'll be able to jump maybe from this step to this step. You'll be able to see this pattern and be able to go straight to n squared plus 4n plus 4. It takes a little bit of practice just to get used to the pattern. So now we have two polynomials multiplied. The first one is a trinomial, second one is a binomial. So let's just multiply this as we've done before, where we'll just take the first term and distribute it to both terms. Then we'll take the second term, distribute it to both terms, and then we'll do the same for the third term. So let's start with that n squared and multiply it with the two components of our second set of parentheses. Meaning I'll have n squared times n plus n squared times 2. Now I'll do this for the second term, 4n. So I'll have 4n times n plus 4n times 2. Then my third term going through plus 4 times n plus 4 times 2. So that will give me n cubed plus 2n squared. This 4n times n will give me 4n squared. Then plus 8n plus another 4n plus 8. So now let's just combine all of our like terms. We have n cubed, no other cubed term. We have 2n squared plus 4n squared, so that will give us 6n squared. Then we have 8n plus 4n, so 12n. Then just that 8 plus 8. So if we have some higher power than 2, we can try to just break it up into smaller pieces where we can apply some rules and then multiply our results together. So let's try that again with part B. Let me write it out and then I'll scroll down. So part B gives us 3v minus 2 to the fourth power. So we have 4 of these. Like this could be written as 3v minus 2 times 3v minus 2 times 3v minus 2 times 3v minus 2. We have 4 factors multiplied. So we can group this into 2 squared factors. I could write this as 3v minus 2 squared times 3v minus 2 squared. We could also be a little bit tricky and write it like 3v minus 2 squared, that whole thing squared, because we have 2 squared terms and they're the same and we're multiplying them together. So we could express this in a few different ways. Let's take maybe this middle way, 3v minus 2 squared. We got 2 sets of these. Let's try just expanding one. I mean, we'll get the same thing for both of them. We'll basically get 2 copies. So applying our pattern, in our first set of parentheses, we would have our first term squared, 3v itself squared. We have a minus here, so minus 2 times our first term, 3v, times our second term, 2, plus our second term squared. We basically have the same thing in our second set. I could write the same thing again, 3v squared minus 2 times 3v times 2 plus 2 squared. So what would that give us multiplied out? 3v squared, 3 times 3 is 9, and then v times v is v squared. Then minus 2 times 3v times 2, so 2 times 3 times 2 should give us 12. So minus 12v plus 4. So we get this times itself. So let's multiply these together. We'll use that same process. I'll just take the 9v and multiply it to each term. So 9v squared times 9v squared. 9 times 9 is 81. And then v squared times v squared, those exponents will add together. So 9v to the 4th power. Why don't I write it out? Let's write out the multiplication just to show everything. So we would have 9v squared times 9v squared. Then multiplied by the second term. So plus 9v squared times negative 12v. Now over to the last term. Plus 9v squared times 4. Now let's take our second term, the minus 12v, and do the same. Put it through to each term. So I can say plus negative 12v times 9v squared. I'm running a plus here. I could write this as a minus, but I tend to just be careful with parentheses. Plus negative 12v times the second term, so times negative 12v. I'm going to keep writing down here, plus now negative 12v times 4. Now let's do the same thing with that last 4. We'll multiply it to each term. So plus 4 times 9v squared plus 4 times negative 12v plus 4 times 4. So it got pretty long here, but let's multiply everything out and then combine our like terms together. So now first we'll get our 81v to the 4th power, like what we had a second ago. 9 times 9 is 81. V squared times v squared is v to the 4th. Then our second term should be negative. We have 9 times negative 12. So that will be minus 108 v cubed, because we have v squared times v to the 1st power. plus 9v squared times 4. So 9 times 4 will give us 36. And we have our v squared. Then notice we'll get another minus 108v cubed. So we get another one of those. Oops. Then negative 12 times negative 12 will give us plus 144. And we have v times v, so v squared. Then 12 times 4 is 48. It'll become negative. Negative 12 times 4 will give us minus 48 v to the first power. Then here we get another positive 36 v squared. 9 times 4. Then 12 times 4, we will get another minus 48v. And then 4 times 4 will give us 16 at the end. So we just need to be super careful as we go through, since we have a lot of terms. When it gets really big like this, it's useful to just double check as we go through, double check our calculations, did things work out. But as long as we're multiplying things correctly, everything should simplify from here on out. So let's try to combine all the like terms that we see. I don't see any other v to the fourth power terms, so we'll keep that 81 v to the fourth. Now I'll look for my v to the third power terms, and maybe I'll even cross things out as I add them below, so I don't double count anything. So looking for v cubed, I see I have this minus 108 v cubed minus another 108 v cubed. So those will combine to negative 216, because I got 2 hundreds and 2 eights. So minus 216 v cubed. So we'll go ahead and cross those out, combine those together. Now what v squared terms do we have? We have this 36v squared, 144v squared, and then another 36v squared. So 36 plus 144 plus another 36 should give you 216. So this is positive plus 216 v squared. Let's cross those out. Now I'm left with my v to the first power term, so I have minus 48v minus another 48v. So those will combine to become minus 96v. And then we're left with that plus 16 at the end. So we get this big fourth degree polynomial as the result of raising 3v minus 2 to the fourth power. These can get a little bit intricate, but as long as we're careful, we should make it through to our final thing here. So again, with these kind of questions, if you're given some multiplication to a higher power than 2, try to just split it up into squares. So in our first case, we had n plus 2 cubed. We can split that up to n plus 2 squared times n plus 2 to the first power. And then in part B, we had the fourth power, so we split that up into 2 squares. And use our rules there, and then multiply the result together. Okay, so we covered finding the product of something like a plus b times a minus b. So we saw that gave us a squared minus b squared, this difference of squares. We saw squaring a binomial a plus or minus b squared. That gave us a squared plus or minus 2ab plus b squared. And if this was a minus, we had a minus here. If it's a plus, we had a plus. And then we just saw finding higher powers by splitting it up into smaller components. You could always multiply these out just by foiling if you need to, if you forget the pattern, but these show up a lot, especially working with quadratic equations and later on as we discuss factoring. It's good to know and be familiar with these patterns because that can make things go a bit smoother. You can save a few steps. Okay, that's it for this video, and I'll see you next time.